Keep quiet. Please don't talk. Okay. The volume is given by 2n squared or 6n squared, 6nx squared plus 4x cubed. So in this question, you have don't start. Don't sleep. Where's the word you're supposed to give me? Okay. That's all. Where's the that one? Where is that one? I want you to repeat. Remember, I emailed you. That one, that two. Yeah. Give it to me before you go home. Can you be done? Huh? Come again? You do your practice set one now. One now. Give me by 10:30. Okay, so now, okay, so you see, basically, I have a cardboard. I'm holding the side up. This part are the side. Okay, the representing for cardboard side is n by 2n. So the square of side n is removed from each corner. So you all know how we wrap up, right? Cut a corner, we can fold everything together. Okay, so this part you can see is x by x, x by x, x by x, x by x, x by x. Okay, typical NJC style. Inside the question. So now, can I ask you, okay, so now if you look at the board, now you look at the box, now you will look something like this, right? So, okay, so can I ask you, this is the wave, right? Like R, this is the 2R, that is probably like R and Q, right? It's probably like N, so look something like this. Okay, so, how long is RQ? Anyone tell me? How long will RQ be? Very good. So you can see, this is N, this is X, this will be N minus 2X. How long will this be? 2N minus 2X. Clear so far? So from there, you can get the base area out. You can get the base area. The base area will be 2N minus 2X and minus 2. Look like this. Oh, now, then if you put up the side, you plot the side, right? So you can see this is N minus 2X. This is 2N minus 2X, right? Okay, now what will the height of the cardboard be? So, what will the height of the cardboard be? X. Can you think it all? This part. Okay, easy to form the volume, length times breadth times height. Okay, so with that, we take a look. Length times breadth times height. Base, this is the width, this is the length, and this is the height. Easy peasy lemon squeezy. Okay? Anyone more is good. If I don't see anyone copying this, by the end of the lesson, I should be able to collect everyone's practice set form. Okay, I go on. Go on. Aiden, why? Okay now. Ready? Yeah. Let me see. That's all. Wait. Wait. Now, go back. Aiden, can do properly. Okay, don't so lazy. I come around and see. Bye. Who else ever do? Hey, I come to say you move your head. I already go to the solution. You also want to copy. You want to copy. Hey. Where's John? Where's John? Okay, where's John? Where's John? Where's John? Where's the rest of the set? Where's John? Where's yours? Where's yours? Why did you never take out?
It's unless it's just a party pooper. Huh? Oh, then you don't need to go for recess time. Okay. So without finding here a calculator, find in short form the value of x that gives a stationary value. So now I take this, right? Okay, when you differentiate this, you take n is a constant. N is a constant. So you differentiate, you take n as a constant. Remember what? You take n as a constant. Okay. Yeah. Now, from here, 2n squared minus 12nx, you solve. Now, here to here, I use the quadratic formula. Okay, so far? Okay? Okay, so now you see, okay, did they ask for turning point? Did they ask for inflection? They ask for stationary value. Okay, so why do you do second derivative? No need. Okay, so you can see here, you don't need to do. No need. All right? Okay. So why do I reject? Why do I reject this? Because if n is too big, right, and you need n minus 2x to be more than 0. Okay, you need n minus 2x to be more than 0. Okay? So, yeah, this is why you reject this. Okay? Can I? Remember, this is the value of x. This is the value of x. If x is equal to 3 plus square root 36 over n, then n minus 2x is going to be less than 0. That's why you reject. That's why you reject. Okay? Work it out. Anyone who is copying? Can you just raise your hand? Okay, you copying, I wait a while. Can you show me the one which you're copying? Okay. Divya, are you okay? Are you okay? So sorry, I'm just joking. Okay. Where is your practice? Oh. Archie, where's your practice set? Hey, where's your practice set? Have you self-marked? Okay. Okay, I wait a while. Those who are ready to take out your practice. Hello. Take out your notes. We'll start on topic 7. One second now. Excellent. Everything okay? You use the document I sent you. Assignment. Assignment don't give us. Topic 6 assignment don't give us. Actually, you can give us. I think. Okay. Can any more copying? No, I go on. Okay, let's go to topic 7. Okay, topic 7, we will not be finishing it before the June holidays, I guess. So we'll probably stop somewhere around part 2. Okay, now to be good in integration techniques, the assumption is that you must be good with your differentiation as well. Okay, that's why I say it's accumulative. So there's differentiation techniques followed by differentiation application. There's integration techniques followed by integration application. After integration application, there is kinematics. Kinematics, not physics in calculus terms. Because when you differentiate, for example, when you differentiate displacement, you get acceleration. Because acceleration is the gradient of displacement time graph. When you differentiate velocity, you get acceleration. Because acceleration is the gradient of A is dv dt. Okay. So the next four topics, you need to be make sure that you are good with differentiation. Otherwise, you will struggle. That is accumulative. Can so far? Can I? Okay. Now we first talk about there are four parts: indefinite and definite. I will explain what's the difference later on. Now, when we talk about integration of trigo, exponential, and also a bit of logarithm log. Okay. So, what are indefinite integrals? Now, indefinite integral basically, when we talk about integration, is basically the reverse of differentiation, right? So, it can be endothermic, opposite endothermic, exothermic. Right now, there is oxidation, your organic chem, there's oxidation, then what's the reverse? Reduction. You understand? Everything there's a to and there's a fro. When you go home, you will come back. When you go to school, you'll go home. Correct? When you offend, you will defend also. Understand? Can I? So there's always a to and a fro. So integration basically we can say that it's like anti-differentiation. Oh? Can I? So reverse addition, subtraction, reverse multiplication. This one you read yourself. Okay? Square root, power 2. This root. Yes, sorry. Actually, square bracket. Okay. First, let me introduce to you. Okay, so don't worry so much, but you see capital and F, right? This is the antiderivative. Now, if when you differentiate capital to get small, then capital Fx is what an antiderivative. Okay, so how do we express the okay? So maybe you take a look at question 1.1 and I ask you, is the antiderivative of the function unique? What do you all think? No, right? Why? Because, okay, I ask you, if you differentiate x squared, what do I get? 2x. Okay. If I differentiate x squared plus 10, what do I get? If I differentiate x squared minus 1000, what do I get? Also 2x. So can you see that? Okay, we call this an arbitrary constant. Okay, so we call this an arbitrary constant. So when you see, you realize that the entire derivative is not unique because there's some constant that may have passed away during differentiation. Okay, please write it down. Aiyo. Slowly go on. Okay, so you know that when you differentiate a constant in zero. So what does it mean? Yeah, there's some constant that may have passed away. So what do we tell us? The entire derivative is often not unique. Okay, it's always not unique for indefinite integral. Okay, just for your learning. Can I? Okay. Not yet. Okay, wait a while. Huh? Okay. Okay, so I go on. You don't have to copy word for word. Just get the idea will do. Just get the idea. Just summarize it into, yeah, use your brain AI to summarize it and write it down. Okay? Just know that the entire derivative is not unique. Okay? These are the most important. Okay? Yeah. Now, after that, I go on. Now, what's the possible antiderivative of the zero function? If my function, if I differentiate, I get zero, it's possibly anything. Any possible constant, right? That means it's possible any constant. Now, now I go straight to this one. Okay, this is indefinite integral. This is indefinite. Indefinite, basically you will see that basically there's a function that you integrate. Okay, now later I'll go on. I'll tell you the difference between indefinite and definite. Okay. Now, you can see this is the entire derivative, right? So let me write out for you. And I'll just, yeah. Okay. Equal to 2x. Am I right? Okay. What's the name of this? What's the name of this letter? What does it do? What does it do? Louder. What does it do, Sean? Close the laptop. Except for your son. Oh, you close the laptop. Close the iPad. Okay. Emily. Good eye. Okay. Okay, what does this do? This is differentiate, right? So this is differentiate, Okay, so this is with respect to this one is x. Okay, so now I introduce you the integration symbol. Okay, just pay attention. So I'm going to keep saying. Now, in reverse, right? When I do something like this, this is x squared plus. Okay, what does this symbol represent? It looks like the, what do you call that? Careful. What is that? What is that? Why is one that? Okay, so example, this is like the integrate. What you call base plan, right? What you call base plan, right? Doesn't matter. I'm using it here. Okay. Integrate. This action is an action. What does it do? Actually, what does it do? Okay. This means integrate. It's a verb. Yeah. So what does this mean? With respect to x. Okay. Integrating with respect to x. So you need to write these two symbols. Then so far, when I integrate, okay, when I differentiate x squared, I get 2x. When I integrate 2x, look at it. With respect to x, I will get x squared plus what is this equal? Okay. So you need to write this down where t is an arbitrary constant. 5 2. Now, try to write t arbitrary constant. Okay, okay, so you need to write t. Why is there a t here? Let's see. It's because of the difference in differentiation. In differentiation, there's a constant that may have passed away. Remember, there's a constant in differentiation that may have passed away during differentiation. So now, integration will revive the constant back. Is it okay? Can I? So that's why every time we do differentiation, there's a plus t. Okay? There's a plus t, yeah? For now. Those who know of definite integral, you will know why we do. Yeah? So as seen from the derivative, you can see that the constant of integration is arbitrary. Because for any antiderivative, fx plus c, there will be a plus c there. It could be 0, I do not know. it could be 0, but my duty is to tell you that there's someone who's possibly there. Okay? Can I? Now, so if I ask you, okay, is my answer definite? Is my answer definite? Am I giving a clear answer? What time am I going to the zoo today? I don't know. That's called indefinite answer. Okay? Where is Kate going to be president again? I don't know. That's going to be an indefinite answer. Right? Who knows? Maybe SH1 she SH president again. Sean going to be captain again? I don't know. Okay? Can I? So we do not know. You understand? Where is Colin going to win road run next year? That's definite. Okay, Can I? Where is Colin going to win road run next year? Where is the son going to win the AD championship next year? So I'm very clear. Okay, maybe I can bribe everybody. Okay, maybe I can win the game. Okay, but I'm definite. Definite versus indefinite. Where is Yan going to Taiwan? Soon. Okay, Where is Kang Yu going to? Where is Kang Yu going to go back to Clementi today? That's definite. Okay? Can I? Where is Sadhana going to have a boyfriend? I don't know. That's indefinite. I said indefinite. Indefinite. Okay. Can I? What is it? Oh, okay. What from Dubai? From Dubai has a girlfriend? Oh, okay. Got girlfriend? You got girlfriend? Have Okay, congrats. Okay. Okay. So now, okay, we will learn a set of rules. Okay, now you differentiate xn plus 1. Okay, so now you see this, Okay, basically, the differentiation, right? You know what happens to the power? Remember the rule I say power over goes in front. That's number 1. Power drop by 1, right? Okay, okay, so power goes in front is like what kind of action? Multiply or divide? Multiply, Okay, so now I'm going to reverse this. Remember, in integration, we are okay, we are reversing. So in differentiation, this is action 1, action 2, right? Integration, this will become our first action. Okay, and just like your organic chem, alcohol become ester, right? Then become acid, right? Acid become ester. Carboxylic acid. Oh, the things change. I don't know. Okay. Yeah. Power goes in front. So how do I reverse this? This is differentiation, right? So how do I reverse this? What is power dropped by 1? Power at 1. Correct? Power at 1. Now what is action number 2? Power multiplies in front. What's the reverse? Divide by power. Divide by power. Okay, So divide by the power. Divide by the new power. Okay, divide by the new power. Divide by the new power. Okay, so far? Is it okay? So if now I do this, so you see, if I integrate x to the power of 6 dx, what's the action? Action number 1, power over x, 1. Divide by 7 plus power divide at 1, then divide. Clear so far? Now I will ask you, Xingyu, integrate x power 10. Integrate x power 10. Tell me the answer. Add the power followed by divide by new power. Come on. Give me a try, please. $11 plus. Very good. Okay, next one. Yeah. I'm a bit loose here. Okay, can I? Okay, Dora, integrate x power 22. Over 23 plus. Yeah. Okay. Charlie, integrate x to the power 100. Okay. Can I? Okay, what if I want to integrate x to the power of -1? So I want to ask you, if I want to integrate x to the power of -1, what's going to happen? By right, it's x to the power of -1 plus 1 over 0, right? Can or not? Cannot, right? Doesn't work, right? So that's why you see the formula, it will tell you that n cannot be -1. That's so far. But what happens if, okay, don't spoil the fun first. What happens if n is -1? If n is -1, you are looking at this, right? Which is the same as this, right? Now, my simple answer to you, for those who do not know yet, which function? I want to ask, who should I ask you? I don't ask you, but you know answer it. Just someone that you think can benefit. Joshua. Okay, Joshua, let me ask you, which function I differentiate, I will get 1 over x. So if I integrate this one, what do I get? Correct. Well done. Okay. So this will give me log x plus c. Okay, no? Cannot. We will learn that later on. Fun fact. Okay. So without further ado, whatever I say is basically what I wrote here. You take a power, you divide by the power. Okay, you add the power by 1 and you divide by the new power. You're just reversing differentiation steps. Is that okay? Is that okay? Can I? Okay, Hashini looks bored. Okay, so Hashini, whenever you look bored, just look at Aiden. Yeah. Check his work. Yeah. A life of service is a life of meaning. Okay, Aiden got do or not? See, Aiden never do. Aiden, what are you doing? Aiden, you better write something. If not, people think you're a statue. Okay. Okay. So if you're okay, let me now properly introduce you. When we integrate, let me just write again. This sign is called what? What action does this take? This means integrate. This means with respect to x. Then you must know the names of the verbs. Okay, is x to the power n plus 1 divided by n plus 1. Add power divided by power plus c, where c is an arbitrary constant. Do you need to write this in exam? For now, I will tell you yes. I'll tell you yes. Yeah, I'll tell you need to write down where c is an arbitrary constant. Can? Clear so far? Okay, now if you're okay with this, can I ask you also look at the result? Yeah, basically, you know this is going to be log. It's going to be log. Then try question maybe 1.3. Okay? It's not really copying, so I pause for a while. Question 1.3 is very easy. Before you do that, the integral of a sum is the same as the sum of the integral. The integral of a difference is the same as the integral of the integral of the difference of the integral. Okay. Similarly, if I integrate any scalar multiple, I can put it outside. So results 1.5 is basically quite simplistic. It's quite straightforward. I just need you to take a look, read. Okay. And yeah. So we know this one, right? This is the same as integral of 1 over x. So we know that this is just log modulus x plus c. Okay, I just put modulus in case because I do not know what x is. If you're okay, can I ask you to try question 1.3? Can I? Before you look at question 1.3, the result says what? The sum of my integral is the same as the integral of a sum. Okay? And the question itself, we call it an integral. Okay? The function is called an integral. Now, if a scalar multiple, just like differentiation, integration is associative. So this A can be put outside as well. Okay? Just like differentiation, in integration, we put everything to index form. Okay? We put everything to index form. Yes. You get a different. If you how do you get a different differentiation? You get a constant. You get a different constant from the answer. If you are getting a different constant, that means you are able to evaluate the constant, right? Oh, it's okay. It's okay. You also realize that the answer is sometimes not unique. The answer is not unique. That's what we're doing now. Alex. You'll get two different answers. Yeah. Okay, so very simple. If I okay, so you can see, if I write this as 1 minus 4 squared, that's possible. Or if I write this as half of 1 minus 4 squared, that's possible as well. I'll get two different answers. So the answer is not unique. Yeah. Akan datang. Coming soon to theaters near you. Okay? Yeah. Approaching cinemas in July. Okay, yeah? So now I just ask you, which function I differentiate will get? Cosine. Cosine, sine. Cosine is pretty good with cosine. Oh, yeah. I'll come to that later. Okay, now are you all done with 1.3? I'll wait a while.